Hello. Today we're going to talk about double replacement reactions. So first you need to make sure that you have a periodic table available to you before you can start to do double replacement reactions. So double replacement is kind of similar to a single replacement reaction. If you'll remember, single replacement starts with a compound and an element. And a double replacement reaction, I start with two compounds. Okay, so remember that you can identify a compound based off of how many capital letters it has. So here I have 2 capital letters, and that indicates that it is indeed a compound. 2 or more capital letters tells you that you have a compound. So since I do have 2 compounds here that I'm starting with as reactants before my arrow, that means that I am talking about a double replacement here. So what's going to happen is a complete swap. So I have a metal and a non-metal, and another metal and a non-metal. Remember that the metals always get listed first in the equation. Okay, these are also called cations because they're always positive. And remember the word cation, the T looks like a little positive sign. So my metals are also called cations. So what's going to happen here is the first of both compounds are going to completely switch. So my cations, or my metals, are going to trade. So people like to call this the wife swap. Or two groups of people dancing and they're trading partners. Okay? The thing we need to be careful of is that as my products, I need to end with a metal paired with a non-metal and another metal paired with a non-metal. But if you always just underline the first parts of your compound, it'll always work out. Okay, so grab the first one from here, the first one from here, and we're going to trade places. So aluminum is going to end up with chlorine, and barium is going to end up with sulfur. Now I'm going to have to re-crisscross these new compounds. Okay? So remember, compounds crisscross charges, all C's, compounds crisscross charges. So anytime I form a new compound, I need to again crisscross the charges. Now remember, we also discussed that the numbers, the subscripts from my reactants, do not come over with me as products. Okay, unless you're talking about a polyatomic ion, but this one does not have any polyatomic ions. Okay, so need to re-crisscross. So I pull out my periodic table to find the charges. I find that aluminum has a positive 3 charge. Chlorine has a negative 1 charge. So I'm going to crisscross, remember, just the numbers, not the sign. So what I get is aluminum gets a 1 from chlorine, and we don't write ones. And then chlorine gets a 3 from aluminum. So remember, I don't put any positives or negatives here. In the end, I just bring the numbers down, and I don't write ones. And then for the next one, I look up on my periodic table again, barium. So barium is here, which is a positive 2 charge. And sulfur is here with a negative 2 charge. So what I get is, after I crisscross, 2 and a 2, what I get is Ba2S2. However, you'll recall, hopefully, that when you crisscross the exact same number, you need to reduce or simplify it. Okay, so this isn't Ba2S2, they reduce down to ones. Okay, I can divide them both by 2 and make them both ones. In which case I don't write ones. So this is just going to be BAS. Okay, capital B, lowercase a, capital S. Got to be careful on your capital letters. I see some people getting a little bit sloppy. Just follow what the periodic table says. So for example, it's capital B, lowercase a. All right, so this is done. I do need to balance it still. But that's really all you're doing in a double replacement reaction is underlining the first of the elements in your compounds, which will be both of your metals, because metal always comes first, and just completely trade them. So aluminum will end up with chlorine, and aluminum will stay in front in the new compound, because metals always get listed first. So my aluminum metal, when paired with chlorine, will get listed first. Okay? Same thing here. Barium comes over to be with sulfur, and barium goes first because the metal always gets listed first in the compound. Okay? Also remember that we do not bring subscripts over to products. I make new subscripts based off of new crisscrossing. So the whole thing really is just a bunch of crisscrossing. So make sure that you know how to do that. Make sure that you know how to write ionic formulas. Okay? So now we're going to balance this. So for balancing, remember you can make this little chart here. You do not need to if you're getting to a point where you're pretty good at balancing. So I have barium, I have chlorine, have aluminum, and I have sulfur. So my reactants are things before the arrow. So here I have 1 barium, I have 2 chlorines, I have 2 aluminums, and I have 3 sulfurs, all before my arrow, all as reactants. Now my products are things after the arrow. So I have 1 aluminum after the arrow, I have 3 chlorines after the arrow, I have 1 barium and 1 sulfur. All right, so I see that my bariums are balanced. I start with 1, I end with 1. Perfect. Chlorines are going to kind of be an issue here. So I'm starting with 2 and ending with 3. So anytime you see this 2, 3 issue, you're going to have to make them both equal to 6. Okay, so 2 times 3 will give me 6, and 3 times 2 will give me 6. Okay, so I have 3 groups of 2. 3 times 2, 6. 2 groups of 3. 2 times 3, 6. So I start with 6, end with 6. This did kind of mess up a lot of other things though, so let's take a look. Now I have 3 bariums and 6 chlorines, so this goes to everything in the compound. So I actually have 3 bariums to start with, and now I'm ending with 2 aluminums. Okay, which was nice. That actually fixed me up right there. Okay, I was starting with 2, and now I'm ending with 2. So you can choose to either move on to sulfur or go back to barium. It doesn't matter. It's going to get you the same place. So if I'm starting with 3 bariums, I have to end with 3 bariums. There was 1 there already, so 1 times 3 gives me 3. And that also influences my sulfur. So 3 times 3, which actually is exactly what I wanted. Okay, so I end with 3 bariums and 3 sulfurs. I start with 3 bariums and 3 sulfurs. So this is done. Okay, so the most difficult part about double replacement reactions is all the crisscrossing. There is a lot of crisscrossing. Okay, so to recap, step 1 is to swap your metals. Keep the metals in front in the new compounds. Okay, aluminum comes first, barium comes first. Find the charges on the periodic table and crisscross your new compounds. Okay, reduce if you can. And then balance. That's really all there is to it.